We have already started this topic called access control list. We saw that there are two types of access control list that router supports. One is only based on the source. The decisions are made whether to permit or deny. The other one is protocol must. You have to specify protocol, source, IP, destination, IP. These three are mandatory. You should say protocol, you should say source IP address or the subnet, destination IP address or the subnet. We call this as extended access list. Based on these three, if a decision need to be made, then we can use extended access list. Additionally, you can also match the protocol number, like port number. For example, protocol number telnet is 25, TCP 25. Protocol is 25 and the port number of that protocol telnet is 25. Sorry, protocol is TCP, port number of the telnet is 25. So matching port number is optional. You may or you may not have in the match criteria. What is mandatory is the protocol like IP, TCP, UDP must be there. EIGRP, OSPF must be there. Source IP address or the subnet, destination IP address or the subnet. To recall what you have learned in the previous class, I'd like to again go and do another small scenario. You can later compare this one with the previous class video and have more understanding on this access list. Earlier we have written like this. Wait a minute, let me check whether the IP addresses are in place. Okay, IP addresses are in place, but I am seeing a different IP address. I have to give interface gig Ethernet 001 IP address as 172. I'm overwriting with this. I'm overwriting this address with 172.16.0.1. You remember we added this new router in the previous class. So earlier this wire was connected here. 172.16.0.1. I forgot to save these things in our previous class. Let me also go here to router 0. I would like to call this as router 2. Router 2. Interface G000 will be 172.16.0.2. And interface G0001 will be 492.2.1. Am I right? Yes, 2.1.24 mask. Okay. I remember I wrote a default route, so let me also write that now. IP route, any network, any subnet mask. I'm sending it to router 1 just for reachability. 172.16.0.1. Likewise on R1, this is for reachability. Do you understand what I'm doing? Okay. Show IP access list. Let me check. I'm going to remove this access list. Listen carefully. Earlier in our class, we have matched only one single IP address going to a single destination. This time, for a change, I'm going to match the entire subnet 192.168.1, the entire subnet. So I'll remove this access list. How do you remove access list? No access list 150. That's all. Access list is removed. Now let us check show IP access list. You see it's gone. All right, access list is removed. I don't have any access list. Even here, this is a fresh router. Show IP access list, nothing. Now let me try pinging from this computer. This computer IP address is 192.168.1.2. This is 1.50. This is 2.2. And this is DHCP given. I don't know what DHCP has given. It has given 2.3. No, statically given. Anyway, we'll give 192.168.2.3/24. Okay, statically given. And this time, to make it more interesting, I'm going to add another router here. I'm going to add another router. Any router. And this one, I'll call it as in router. That's the name I'm giving. Connect this one. And on this router also, I'm going to give IP address statically like this. 192.168.2.4. Right? Okay. Why I'm doing this? Why am I connecting router? See, with router I can enable multiple services like SSH, Telnet, etc. So we will write an access list to block only Telnet traffic, only SSH traffic. That's what we see in the real world. So first, let us bring this router in underscore router. Interface G00 192.168.2.4. And here also I'm going to write a default route, IP route, any network, any subnet mask. Send it to your gateway. The gateway of this router is who? 192.168.2.1. Okay, so what I'm trying to say is, if I ping from here, I'll be able to ping. If I ping from here, then also I'll be able to ping this router, not only this router, this server, this computer. And I'm going to enable Telnet here. I'm going to enable what? Telnet service. I'm going to enable SSH service. And I'm also going to enable HTTP service. Now, after enabling these three on this router, we'll write some policy like this. PC0 can ping and SSH. PC1 can telnet and SSH, but not ping it. Others can do all. We don't have others. I'm just, I'm going to write permit in area. So this type of policy we need to test. See, PC0, if he pings, he can ping. If he does telnet, no, not allowed. Okay, one more thing I want to allow. Add. Here, HTTP. So PC1 has got privilege of doing SSH, telnet, and HTTP, but not ping. Does that sound to you as a plan? Is it a good plan? Nice policy, no? To test. More granular, more in depth. In the previous class, we just wrote about standard access list. I told you, write the standard access list as near to the destination. If you're writing standard access list, you will write it on router 2. But this needs what access list? Extended access list. Why? Because I have to match some protocols. Telnet SSH. Do you agree? Do you follow? Okay. Let me first go to this router. Enable telnet. How to enable telnet? Focus. Line VTY 0. And how many users? I want to allow 5 users parallelly. So 0 to 4. 0, 1, 2, 3, 4. I don't have 5 users. Just, this is what industry do. If they want, they will allow 5. You can also allow up to 15. And I'm going to say transport, input, SSH, and telnet. SSH, telnet. I don't know whether this packet tracer supports both. Let me check. Show run will show you what all enabled. Oh, sorry, whatever I gave last, no, only that much is allowed. Yeah. This is a packet tracer. I cannot enable both telnet and SSH together, so I'm going to change the scenario. Sorry. I'll remove SSH from this list. We'll test only with telnet, ping, and HTTP. Okay, so this is the story. PC0 can only ping this router. No telnet, no HTTP. Whereas PC1 can do both telnet and HTTP, but not ping. And I'm going to add another computer. And for this, I'm going to give IP address 192.168.1.25. He can do anything. He can do telnet, he can do HTTP, he can do ping. All right, so let me give IP address to this. Yeah, so this is what we're going to test. We have added additionally one PC, and I have enabled telnet here. Let me also enable HTTP here. On the router, IP, HTTP, let's give a domain name, IP domain name, abc.com. IP do we have HTTP service? TCP, no. Sorry, this don't support HTTP. Let me try whether this router supports. Sorry, this is all simulated. This don't support HTTP. Anyway, we have HTTP here. You remember the other day I was showing you when I typed that IP address from here. Give a second. It's opening. When I say 192.168.2.2, I'm able to get this page. See, I got the page. The HTTP is working. And this should work from all other computers. Because we don't have any access list blocking right now. I have removed the access list. My browser will always take a couple of seconds to open. I clicked log back. Please wait. Meanwhile, let me also go to this new PC. It's a response time. Here, let me paste this. Sorry. Stop vomiting. So we can see all three PCs, PC1 and this new PC and also PC0, all three can see the web page. Now let us change the policy. PC0 can ping who? Ping IN_RTR. No one else is shipping. And he can do HTTP to server. Right? That's the policy. PC0 can do it. But PC1 should not do ping, but he can tell it to router and do HTTP to server 1 and ping only to PC-PT. Oh, sorry, I don't want to mention like that. I'll call it as PC3 and I'll name this as PC3. I don't understand why it takes so long. This is the policy that we are trying to achieve. On this router, we don't have SSH, we have only telnet. Whatever is said here should be seen. See, for this PC 1.25, we don't have policy, which means it falls under policy number 3, others. This can do HTTP, this can do ping, this can do telnet, this can do everything. So we need to write an access list. If I write here, what will happen, after coming all the way down here, if the policy is denied, then it will get denied. The waste of processing here and waste of bandwidth here. So right here itself, you can check whether he will be allowed, the traffic will be allowed to the destination. Stop right here itself. I repeat, when you write the extended access list, right near to the source. Why? In the source itself, you can check whether the traffic will be reaching the destination, allowed to reach the destination. If yes, you allow. Otherwise, deny here itself. There is no need for wastage of bandwidth in the path, wastage of CPU on router 2. Let me put it in Tamil. The extended access list R2ல எழுதுறதுக்கு பதிலா R1ல எழுதிட்டீங்கன்னா நல்லது. ஏன்னா R1 பார்க்கும் இந்த சோர்ஸ் அந்த டெஸ்டினேஷன் போலாமா, போலாம், சரி அப்ப அனுப்பிடும். இந்த சோர்ஸ் அந்த டெஸ்டினேஷன் போகலாமா, போகக்கூடாது, அப்ப இங்கேயே நிறுத்திட்டா தேவையில்லாம அந்த ஒயர்ல பேண்ட்வித் யூஸ் பண்ணாது. ரவுட்டர் 1க்கும் ரவுட்டர் 2க்கும் நடுவில் இருக்கிற ஒயர்ல ரவுட்டர் 2ல சிபி யூஸ் பண்ணாது. இங்கே ட்ராப் பண்ண நல்லது. ஏன்னா சோர்ஸ் டெஸ்டினேஷன் எல்லாமே இங்கே செக் பண்ண முடியும் போது இங்கே பண்ணிடுறது நல்லது. பட் த ஸ்டாண்டர்ட் ஆக்சஸ் லிஸ்ட் இஸ் நாட் லைக் தட். யூ டோன்ட் ஹேவ் அ privilege of matching destination. So you must write only on R2. Standard access list has to be written only on router 2, which is close to the destination, because we match only the source. Fine. Our focus is today on the extended access list. Let me write down this extended access list in a notepad so that you will understand. And then I'll take you to the command line. I'm writing in the notepad, you see. I'll go to the router and type enable config t. And then I'll say access list. What number I should use for extended access list? No. 100 to 199. So I'm going to say 101. And I'm going to say permit. See, the first protocol is ping. You need to permit ICMP. So I say permit ICMP from one particular computer. So you use the keyword host. What is the computer IP address? PC0, which is 192.168.1.50, isn't it? .50. Now this 1.50 is allowed to ping INT RTR. Only ping. What is the IP address of INT RTR? 192.168.2.4. Next, what he can do? Copy this line. Paste it again. Same number you should use. He is allowed to use HTTP service, which means TCP. And the destination address for HTTP server is what? This one. 2.2 equals 80. You understand this 80 because it is HTTP. These two are permitted. Done. Next. What is next? PC1. Access list. Use the same number. 101. Permit. You're going to permit telnet for, so TCP. See, I made spelling mistake. TCP from the host. PC1's IP address is what? 192.168.1.2. To host. Telnet to whom? In RTP, which is this guy. 2.4. This one. Equals what? 23, because it's telnet. Next what? He's allowed to do HTTP also. He's allowed to do HTTP. So copy this. Or copy this line. This is also HTTP line. Put it here. And change this to 2. So this is PC0's address. Sorry, PC1's address. PC1 can do HTTP. Yes. Next. What he can do? He can ping this PC3, meaning only ICMP is allowed. So copy that first line here. Ping is ICMP. From host is 2. To host is this new PC, 2.3. He can ping, but he cannot do telnet or SSH. Did you understand so far? Now, you see, others can do all. Who is the other? This is the only guy. So right here, access list 101 permit. What permit? Thank you. 101 permit. You see, this guy can do all. Means what? IP. IP means all protocol. It includes ICMP, telnet, everything. From host to any. That's all. He can go to anywhere, do anything. Now, other than these things, for these guys, other things are denied. You remember, there is an implicit deny at the bottom. You remember, there is an implicit deny. Whatever is not permitted here will be denied. Problem solved. I need to simply just paste this, that's all. My access list is almost over. I need to apply this to an interface. First, let me paste it. Okay, it is applied. I need to apply this, or it is configured. We need to apply this to interface. See, if I am applying to this inside, if I am applying to this G00, I should put in, and the traffic is coming from this side towards the router in. If I will write it in this interface, then I should say, oh, out. Tell me which interface I should use. Your wish. You can tell me any interface, G00 or G01. Where should I apply this access list? Anyone you tell me. Which should I use? In or out? 000. Okay, 0. Then which means I have to say in, right? So that also I'm going to use the notepad and say interface G000 IP access, not the list command, it is group command. Under the interface, see, this is the single line is list. This is group of lines, so you have to use the group keyword. Group 101 in. So I'm going to paste this further out. I pasted it. Done. See, we are going to just verify now. First thing, I'm going to verify this. Listen, when I ping from 1.50 to 2.4, I should see some match. Let me go there. Sorry. 1.50 is this. From this computer, hold on please. It's not closing. From this computer, I'm going to ping, what is the policy? 2.4. 192.168.2.4. You see, it's going to ping. If routes, everything is good, it will ping. Okay, it is pinging. It is pinging. So how do I know that the access list is matching? Come here now. See, earlier there was no match, but now you see there are 8 packets matched, which means this is working fine. Because the policy is permitting, it is permitting. Otherwise, it will not permit. Second, I want to check whether this HTTP to this is happening. So for that, I'll go to that same computer, 1.50, open HTTP. In Sodanidu. So I'll go here 192.168.2.1. I should see HTTP page. Is it true? Oh, it's not going. Where is the access list? If I go, it's 2.2, not 2.1. Sorry. 2.2. 2.2. The gateway is 2.1. I put a wrong address. 2.2. Okay, I got the page. Let's go and check whether there is a match. So earlier there was no match, but now you see there is a match. So this also proves that it is matching this policy. If I would have said denied, this would have not happened. Okay, now let's check this one. Telnet. From here to the router. Who is this? 1.2. 1.2 is this computer, PC1. From here, I'm going to do telnet to the router, newly added router. This is the newly added router. 192.168.2.4. Telnet. Oh, it says close by foreign. You know why? Because I did not set the password. But anyway, the match would have happened in the access list. Let's check that one. Earlier there was no match here, but now the match should have happened. Look at this, 3 packet matched. But why I was not able to log in? Because I did not put the password. Who is foreign host? That router. Router is saying I am not going to allow you inside. Telnet is open, but I'm not going to allow you inside. So let's go and put the password. Line VTY04 password. I'll say Cisco. Now you go on Telnet. It's asking password. I'm typing CISCO. See, I'm able to see the router. Earlier it was PC's prompt. Now I'm seeing a router, which means Telnet is successful. Let's go here and check the access list now. Earlier it was only 3 packets, but now I'm expecting more, 24 packets. Okay, next. From the same computer, if I do www to 2.2, I should be. So I'll go here. Sorry, I'll go to this PC again. I'll exit from this Telnet and I will open the browser. Now, let's say 192.168.2.2. I should see the page. I'm seeing the page. Now, what is next? According to the router, there should be a match here now. If I go and check the access list. Oh no. You see there's a match here. Now let's ping and see from this to this new computer. 1.2 to 2.3. 1.2 is here. 2.3 is this new computer. I should ping. Ping to the new computer. Ping 192.168.2.3. This ping should happen. It is happening. So I should see a match now on the router. You see there's a match. Now I'm going to ping from this computer. I'm going to do HTTP from this computer. I'm going to do everything. Telnet, everything should work from this computer because destination is any. Okay. I'm going here and I say go to check whether HTTP is happening. If it is happening, I should see some match here. Because I put IP, it includes TCP also. You see there's a match. Now, from the same computer, I close this and I'll try pinging. I'm going to ping all 3 computers from there. 192.168.2.2 first I'm pinging. And 2.3 also pinging. And what about the router? Router is 2.4. I'm pinging. Not only that, see, I'm doing HTTP here, I'm pinging. I'm also going to do Telnet. Cisco. Look at this. All are permitted from this computer because the policy says he can do all 47 packet. Now we have seen our policy getting matched. Whatever need to be permitted is very well permitted. Now let us see whatever should be denied, whether it is denied or not. Please look at this. What should be denied on PC0? Tell me. From PC0, what should be denied? We need to test that one. From PC0, what should be denied? Yeah, சொல்லுங்களே. Permit ஆனது தவிர மீதியெல்லாம் denied. மீதினா என்ன இருக்கு? Telnet should be denied. Let's check. PC0 should not allow Telnet. Telnet to 192.168.2. What is the address of the route? 4. Ping was happening, but Telnet should not happen. You see, it will be keep on trying, and then it will come out. It won't say open, give me the password, nothing, because it is blocked. See, connection timed out. Remote host is not responding because packet is not going in first place. Okay. Second, from PC2, what do you want to test? PC2, I should not be able to ping the router, and I should not be able to ping the HTTP server. Do you agree? I should not ping these two guys. Yes or no? Server is only allowed for HTTP, and router is allowed only for Telnet. So, if I go to this PC and do, if I go to the PC and ping the router, I should not ping. Ping the router 192.168.2.4. See, it says destination host unreachable. Unreachable. Sorry, pa. I cannot reach, pa. Who is telling this? Your gateway is telling I'm not allowed to go. Sorry. And I'm not able to. I should not be even pinging the server. Server is 2.2. See, again, same. That's all. We have tested all. Do you understand? I want you to go through this class video and previous 2 class videos and complete this topic